मैं पढ़ने के लिए आया हूँ।
Hey everyone, welcome back to another webinar that is been hosted by PyNet Labs Private Limited. My name is Abhijit, and I'm the co-founder and CEO and as well as master trainer at Labs Private Limited. We deal in various technology and domains that that focuses more onto network automation. That's why we are kind of known as network automation specialists, and we do deliver our corporate services to most of our public as well as business clients in terms of delivering trainings, in terms of providing consultancy with projects that are focused more towards network automation. So this is another webinar that is being posted. This is another webinar that is being posted, and okay, I see audio is not that, so let me check that.
Hi,
All right.
Abhijit. Yeah,
Can you hear me now?
we are not able to. I think it's better. Could you please say something else again?
I hope my voice should be better now.
Yeah, it's much better than before. Thank you.
So, yeah, I guess we're good to go. Perfect. So I was saying that welcome back to another webinar that is being organized by PyNet Labs Private Limited, and I hope you all are doing good. We have organized this particular webinar in order to introduce you guys with the latest and cutting edge technologies around the network automation. Since at PyNet Labs, our main focus is to deliver trainings and our corporate services to projects that are focusing towards the network automation domain.
Hey, hi, Saras. Can you mute everyone else apart from Abhijit, please?
Yeah, it's done. I think it's good to go now.
All right.
I think Abhijit was also on mute. Okay, fine.
Yeah. Good. So, guys, let's get started. As I provided the introduction, the webinar is going to focus on the technology, which is majorly towards pyATS. So, when we speak about pyATS is a tool that is used in order to perform network validation and tests. So we're gonna see how this particular framework or how this particular, you can say, library helps you to fetch out the configuration as well as compare configurations, create backups into network devices, and understand the use of it. So if I give you a brief history about what's pyATS and is there any full form which is associated with it, we generally call it as network testing framework. And it was originally created by Cisco for their internal testing. Now, since I've been delivering a lot of trainings and a lot of consultancy towards the network automation, I often get asked with questions that are about how do we basically manage a large inventory? How do we check whether the configuration that is being deployed on one at a certain time is correct or not? Or since there is so like I said, that whenever I often come across questions that whenever we are trying to, you can say, managing a large inventory, then there are configurations which gets pushed. There are configurations which gets fetched, and there are often changes to the configurations that happens. If we have certain devices, for example, there is an administrator who is trying to manage an inventory of devices. So let's say there is a switch that manages, let's say we have a router 1, and then we have a router 2, and then we have a router 3, router 4, and router 5. And these routers internally, let's say, are connected together. R1 with R2, R2 with R3, R3 with R4, and R4 with R5. And maybe there is an R6 and there is an R7, which again are connected together. And in this way, they are forming kind of an OSP of neighborship with each other. So if there is a neighborship from R1 to R2 and R2 to R3, definitely whatever network that R1 will be advertising in the OSP of domain will be received by R2. And whatever network that R2 will be advertising will be received by R3 and R1. And then they will be propagating that information ahead. So while these network informations are being propagated with the help of the protocol that is being used, we ensure reachability, that R1's, let's say, loopback, that is 10.0.0.0/24, is able to reach out to R5's loopback, which is 50.0.0.0/24. Now, either they use this particular path or they use this particular path. It depends completely on the availability of the path. Primarily, if we look at the concepts of OSPF, then according to the shortest path algorithm, the OSPF is going to choose this path to reach out to the destination because it requires you to cross minimum number of hops. But let's say that this link goes down, right? And then there is the alternative path, which basically takes place. So you will get to know that my primary path has gone down and I need to do something. I need to maybe troubleshoot my network. So what would you do? You would basically see the routing table mostly. You'll go on R1 and say show IP route. And when you do show IP route, you're going to see that I have learned 50.0.0.0/24, which is an OSPF route. But I am learning that route via R2 because the route advertisement is coming this way, not this way, because the link is down. And you might also use OSPF command that let me check what all are my OSPF neighbors. So I would say show IP OSPF neighbors, and I will get to know that I am only neighbor with R2 and not R3. This lets me know that R3's neighborship is down. What can I do there? So then you would perform ping reachability and basic troubleshootings can be done. But doing this is quite fine whenever the inventory is a bit smaller and not that big. What if there are, let's say, scenarios where you are required to manage around 100 devices and 200 devices, and there are neighborships. There is a multi-area OSPF scenario which is being maintained. And then there are, let's say, backups of configurations which are taken generally. So in those scenarios, it will be hard for you to get to know that at what point the fault actually relies. Okay. Is it the fault that is on R1? Is it a fault that is on R2? Is it a fault that is on R3 or so on? You will have to check whether the configuration is gone wrong, or whether the cable has gone wrong, or there is something else that is messing up the connectivity and our primary mode of communication. Other way, this is one use case that in order to identify the fault of the network. Another use case or a problem that we may face, that generally production environments do maintain configurational backups, right? The backups helps the production environments for themselves to keep update, for themselves to stay updated, so that the whatever configuration is being pushed onto the device, if the configuration is lost due to any inactivity or due to any you can say breakdown into our network, then the last and the available configuration is the latest configuration that we have, and not a backup that has been taken a month ago or so. So production environments do follow backup activities every now and then. And these backup activities are performed maybe in some maintenance window, or maybe every night, or maybe in the time when the network usage is quite low, according to, so the traffic is not that much, right? But even to do that, it is kind of a repetitive job for a network engineer to perform backups on, let's say, 100 devices or 200 devices or 500 devices. That's another thing. Another use case, if I give you, that whenever a configuration is actually being pushed, the configuration is not correct according to its functionality, or not correct according to its syntactual representation, or something else may go wrong. So you feel the need of something that can validate the configuration before getting pushed, or even after being pushed or getting pushed, if the configuration that was done onto the device was correct or not. Such kind of requirements or such kind of issues are often faced. So that's exactly where pyATS comes into picture. Now, pyATS, which is generally known as Network Test and Automation Solution, it was originally developed for internal Cisco engineering use. Okay, so Cisco generally uses it basically for its internal users, so that they can test all the configurations which are done. Okay, pyATS, if we speak about it, it provides you the sanity, it provides you the feature, it provides you the solution, it provides you the system and scale, mostly, right? pyATS provides sanity, feature, solution, system, and scale test and verification in terms of the automation for the products that you do. And the products that you're performing these tests can be routers, can be switches, can be access points, can be firewalls, or can be any customer premises equipments, CPEs, to which we call them, right? So Cisco was using it internally completely, but now Cisco have made it publicly available, where anyone can use this network testing framework, okay? And using that framework can ease down the way how devices are managed, the way how devices are tested. So that's what pyATS generally is. Now, how do you, or where do you get to learn about pyATS? If we speak about the full-fledged use cases, then pyATS is getting considered as one of the DevOps tools, which basically eases the operations. When you speak about DevOps, DevOps is nothing but a combination of development plus operations. That's how DevOps is made. So development means using the tools that are required for performing development. This includes then Python, this includes then Postman, this includes any VS Code, the IDE that you use, or PyCharm, or any particular thing or set of tools which you use for development. And operations generally tend to be about how do you manage all the development that's happening. So be it managing the code which is being developed by the entire team. There are 10 members in your team and you want to manage that. So you would preferably use Git, or you would preferably use GitHub. And in order to automate things, you possibly might use things like pyATS to test the development that is happening. You might use the NSO, which is the orchestrator, in order to orchestrate the configuration on multiple devices and to be able to manage the entire inventory from a centralized point of touch. You might use CI/CD pipelining in order to initiate changes to your network infrastructure in an automated fashion, right? So there are combinations of tools which are used. pyATS is one of the tools that comes under the umbrella of DevOps. And since it has been made public, there are various people or various organizations which are consuming the use of this framework in order to perform the network validation and network tests. So installing and using pyATS, it is quite easy. The webinar is going to be focused on the fundamental use cases of pyATS. How do you install pyATS? How do you make pyATS communicate with the network infrastructure that you have, and what all can be the use cases? So what we're going to do is we are kind of going to create a topology that actually communicates with the system in which we have pyATS installed. And then by using pyATS, we will try to take backups of the configurations that are available. And whenever there is any change that happens, there is any fault that happens into your topology, then how pyATS can help you identify the threat or identify the misconfiguration of the device, right? By doing comparisons of the backups that were taken from the network infrastructure or so. But first, let's try to understand how pyATS generally is divided. So the pyATS base platform framework specializes into data-driven and reusable testing and is engineered for rapid development iterations. Okay, you can say that pyATS has number one as its library system. So the library system is kind of identified as Genie. Okay, this is the standard pyATS network device library. So Genie defines how network engineers perform testing and scripting. It comes out of the box with all the bits needed for network test automation, meaning that the network engineers with the DevOps knowledge can be productive, you can say, towards their day one activities with Genie's readily availability in order to perform checks and perform tests that ensures that the device connectivity is up, the APIs, let's say, in a bigger infrastructure is available. Okay, then there are pool of reusable test cases which are already defined. Then it also provides you the tests where you can check the BGP connectivities in your network infrastructure is up, the OSPF connectivity is up, and all that. So it contains a library of all the test cases, the basic test cases that you can perform for your infrastructure. And apart from that, the pyATS also provides you a UI dashboard. So it provides you a GUI, which is called as Espresso. So when you use pyATS along with Genie, okay, the users can build highly powerful and custom tailored scripts and test suites for their own business purposes. And these scripts naturally run in, you can say, shell or in a text format or in a pure Python environment where you use an IDE to write down your code and so. Once comfortable with scripts functionality and flow, you will need a place to kind of store all those scripts. So you basically use Espresso in order to store all your developments. Okay, and then by using the UI UX features of Espresso, you will be able to rapidly manage all the test case and trigger the test case whenever you require them. So you can do the test suite management, you can do the test weight and the inventory management, you can do the execution of tests, be it the on-demand execution, be it the bundle runs, or whatever kind of executions you do. You can also view the tests live when they are running by using the Espresso. So it is kind of suite of tools which are available. Now, on what devices by default it is supported? So pyATS is supported on number one, it is supported on iOS. Number two, it is supported on iOS XE. Number three, it is supported on iOS XR. Number four, it is supported on NXOS. Number five, it is supported on ASA, right? And etc. there are a lot of operating systems and a lot of platforms of Cisco upon which pyATS can be executed, which means pyATS can identify the configurations of all these particular devices very well. And it is not even limited for only and only Cisco's platforms. They are expanding their support towards other vendor devices and so on. The connections, however, are created by using various methods. You can create, so there should be a communication method from your device to the infrastructure, right? So there you can create CLI connections. You can even use modern and advanced network configuration protocols like in the netconf and restconf. All these can be used in order to initiate connections with your devices. And there are also third-party platform supports for other management protocols that can easily be achieved through plugins and libraries. For example, SSH and all those things can be used in order to create connections with your devices and so. So that's a bit of an introduction of what pyATS generally do. If you have any questions to understand this, you can put them and park your questions in the chat. And meanwhile, as soon as I see those questions, I will keep on answering your questions easily. What we're going to do now is in the admin machine, I basically am going to log in into my Ubuntu box. And on that Ubuntu box, I'm going to get connected with my topology. We're going to create a small topology of, let's say, some 3 to 4 routers. And then we will be checking whether we are able to connect with those devices or not. Once we feel that we are able to communicate with these devices, then we will use pyATS in order to communicate with the device and try to, you can say, fetch out their configuration, whether the configuration is working fine or not. That's something that we're trying to do. So let me share my other screen and then we will kind of get started with that. So that's my screen. I'll just get connected to my Ubuntu device here. Just a minute. So what we will be doing is I'm going to use a simulator engine, network simulator, in order to create a small topology. So I'm going to power on my Firefox browser in order to access my topology. I'll just get connected with my device. Search for Firefox. There you go. And I'm going to log in into my EVNG, saying admin and EU. And this is where we're going to create a fresh pyATS test, a new lab in which I'll take a couple of routers. So let's say I'll take a router there. And I'll say I want to take around 4 routers. I'll name them with R prefix, and the RAM for every router is going to be 512. And I think we're good. I'll put router number 1 here, router number 2 here, router number 3, router number 4. And then to make these devices communicate with my Ubuntu box, I'm going to put a network there and select cloud 1 as my connecting interface and connect all these devices together. So using R1, R2, R3, and R4. I'll connect my R1 to R2 also. Then R2 to R3 using the next available gig internet interface. And then R3 to R4. There'll be some subnets. So according to the lab configuration, I need to put up a subnet, which is 10 to 55, 1.0. /24. That's the subnet that I'm going to use for my cloud connectivity. And according to that, I'm going to use 10 to 55 1.101 here. Then I'll be using 10 to 55 1.102 on this side. 10 to 55 1.103 and 10 to 55 1.104. Post that, since what we're going to do now is we are also going to create an OSPF domain between R1, R2, R3, and R4. And that domain will be kind of a single area OSPF domain. Okay. So let's say we're going to have OSPF area 0. Being created. The subnets between the links of our router are going to be 12.0.0.0. Then over here, we'll be having 23.0.0.0. Then we will be having 34.0.0.0. And every device will have its loopback interface. So we're going to have router 1's loopback. That's going to be 10.0.0.0/24. Router 2's loopback. That's going to be 20.0.0.0. Router 3's loopback, which will be 30.0.0.0. And router 4's loopback. That's going to be 40.0.0.0/24. Right? These are the loopbacks that we're going to have. I'll start all of my devices. And the type of configuration that we're going to do on these devices, kind of a minimum configuration in order to enable this, is first, we will be configuring the management interface. So GI 0/0 of all these devices are going to be kind of a management interface. Devices coming up. Our devices are in same state. Just perform the no command so that they don't enter into the startup configuration mode. And R1 is quickly say enable config T, host name R1, interface GI0/0, IP address 10 to 55 1.101, along with the subnet mask, no shutdown, and take an exit. Similarly, we are going to enable the SSH access on the device. So IP domain name abc.com, crypto key generate RSA modulus 1024. Then we're gonna say IP SSH version number 2, username admin, privilege 15, password Cisco. And then line VTY 0 space 4, login local, transport input all. After that, we're gonna configure interface GI0/1, and that's gonna be IP address 12.0.0.1 along with the subnet mask. I will use a description connected to R2, then no shutdown and take an exit. Similarly, I'm gonna create a loopback on the device saying 10.0.0.1 along with the subnet mask, and we're good. So if I check at the total interfaces, I configured gig 0/0, gig 0/1, and loopback 0. And these two interfaces, gig 0/1 and the loopback 0 interface shall be participating into my OSPF process. So I'm gonna go and say config T, router OSPF1, router ID 1111. Okay, take an exit and go to interface GI0/1 and then comma, interface range GI0/1, comma, loopback 0, IP OSPF1, area 0, and then right. That's gonna be my R1's config. Quickly, I'll do configure the same thing onto R2. Enable config T, host name R2, then IP domain -name abc.com, crypto key generate RSA modulus 1024, IP SSH version 2, line VTY 0 space 4, login local, transport input all. Username admin, privilege 15, password Cisco. Right? And then we will jump into interface configs. So there, description connected to management, no shutdown, take an exit. Similarly, 12.0.0.2 along with that description connected to router 1, no shutdown, take an exit. Interface GI0/2, IP address 23.0.0.2, no shutdown, take an exit. Oh, I forgot the description. Connected to R3. And interface loopback 0, IP address 20.0.0.1 along with subnet mask. Oh, okay. IP address 20.0.0.1 and no shutdown, take an exit. Then router OSPF1, router ID 2222, interface range GI0/1-2 and loopback 0, IP OSPF1, area 0, and then right. This way, you shall have the neighborship between R1 and R2. There you go. There is an OSPF neighborship change. So if I see at my show IP OSP of neighbors, we are neighbors between R1 and R2, and I shall also have the OSP of routes in my routing table. There you go. So if I try to ping to my loopback from my loopback of R1 from loopback of R2, then the communication is working fine. Similarly, we got to go on to R3 and then say enable config t hostname R3 interface 10 to 55 1.103. No shutdown, take an exit. Then interface gi0/1 23003. No shutdown, take an exit. Right? And IP address 34003. No shutdown, take an exit. And lastly, interface loopback 0, IP address 30001. So we should have 4 interfaces configured. Perfect. Okay, I think I might have swapped these interfaces. On R3, GI0/1 should have 34 and GI0/2 should have 23. Yeah. So I'll say the default interface range GI0/1-2. And then go to interface GI0/1, IP address 34003. No shutdown, take an exit. Interface GI0/1. Oh, did I do the same thing again? No, interface GI0/2, IP address 34003. 23. Okay. (23.003). No shutdown taken. So do show IP interface brief. And I think we are good. Then I'll say router OSPF1, router ID 3333, and interface range GI0/1-2, and loop back 0, IP OSPF1, area 0. And then finally, we will be configuring the SSH. Crypto key generate RSA modulus 1024. IP SSH version number 2. Username admin, privilege 15. Password Cisco. Then line VTY0 space 4, login local, transport input on, and then right. And the last route. Enable config t hostname R4, interface GI0/0, IP address 34004. I think we just have one interface, and then loop back 0, 40001. Perfect. Router OSPF1, router ID, interface range GI0/1, loopback 0, and IP OSPF1, area 0. And then IP domain abc.com, crypto key generate RSA modulus 1024, IP SSH version number 2, username admin, privilege 15, password Cisco, line VTY0 space 4, login local, transport input on, and then right. And we are all good. So our topology is ready. Everything is fine. If I just check the routing table of R4, I should have all the OSPF routes. So I have 10, I have 12, I have 20, 23, 30, and 40 is local. So our OSPF is working all fine. Now that the scenario is ready, in that particular case, I'm going to install go to terminal, and we are kind of going to install pyATS. So what we're going to do generally is we're going to create a test case by creating a virtual environment, and we're going to see how that generally works. If I check, I'm going to go to my desktop directory. On my desktop directory, I have a folder called devnet test. So I'm going to go to devnet test. And inside this, I have a folder called pyATS. So I'm going to go to pyATS. This is where we're going to kind of activate our virtual environment. So I'm going to jump and say Python 3 -m virtual environment. The virtual environments help you keep all the libraries and all the, you can say, installations and dependency installation that you do in Ubuntu isolated from the other things. It doesn't install everything globally. And I'm going to activate that virtual environment saying source bin/activated period. So that's our environment. Now, simply to install pyATS over here, we can simply say pip install pyATS with full capability. So there are various options that we can use in order to install pyATS. Since pyATS, if you just want to install pyATS library, which is Genie, you can simply say pyATS. Instead of full, you can replace full with Genie. If you want to install the complete pyATS, then you say pyATS full. If you want to use, there are other frameworks also along with that. If you want to install the robot framework, then you can say pyATS robot. If you want to just say core framework only, no Genie and no Express or nothing, you can just say pip install pyATS without any full parameter or so. So what I'm going to do is I'm kind of going to install pyATS. I might have, since the requirements are already satisfied, which means I have a cache downloaded. The installation takes a bit of a time. So I already have kept the cache ready in my machine so that it doesn't take that much of time. And we can check whether the pyATS is installed or not by performing a command that says pyATS check version. Okay, sorry, pyATS version check. And there. So all the modules that it has installed, you see the version of the pyATS is 22.11. That kind of gives you the assurance that we have pyATS available. Now, once the pyATS is installed, then you can simply, so pyATS generally works with test beds. Now, what are test beds? Test beds are kind of YAML files which stores the information of your inventory. Since we have all of these devices available, the R1 has some management IP address. Along with that, it has some version of operating system, then some platform, then some enable password, and some IP addresses associated with its interfaces and all that, right? So test beds is kind of the details of the inventory that you have got. And by using the test bed, pyATS will be able to connect with the inventory information that you have. So creating the test bed is quite easier. Now there is a default Genie engine which allows you to create the test bed file easily. You can either create it manually by using any text editor and then create the test bed file. Otherwise, it will help you create it by asking you or prompting you to fill up the information about your network inventory. Since you know what's the management IP address, since you know what's the interface that is interacting with the other device that is connected with R2 or R1 or so on, it will just take basic details from you. So what I can do is I'm gonna jump there and I'm gonna create a directory. Let's say mkdir webinar _ pyATS. And in this, I would say Genie, which is one of its, there are various commands that you can use. Genie is one of the command under pyATS that you can use. And I'll say Genie create test bed. So we want to create a test bed file. You can either create it manually or use the interactive shell that Genie allows you to. So we're gonna create a test bed by using the interactive method, and the output of this particular file will be saved as mytestbed.yml. I'm going to name that particular file as mytestbed.yml. Hit enter. And there, start creating a testbed YAML file. Then it start asking you question. Does your network inventory have all of the devices? Do all the devices have the same username? I will say yes. Then what's the common username? I'll say admin is the common username. Then say, do all the devices have the same default password? I would say yes. Then it says, what's the common password? If you leave this field blank and if you hit enter, then it will ask you the password at the time of the execution. But I will say, I have typed my password and I have hit enter. Then do all of the devices have the same enable password? Even though the enable password is not configured, that's an additional choice. I'll say yes, all of them have a same password. And I will give Cisco as the password there. Though we do not have the enable password configured, all of our users or the user that we have created into all of our devices have privilege level 15. That's why it won't be prompting us for the enable password. Now it says, what's the device host name? So I said device's host name is R1. The first device's host name is R1. Now this name should actually match to the host name that you have configured on your device. Since my device has R1 as its host name, that's why I say the host name is R1. Then what's the IP address of that particular device? I would say 10.255.1.101. Then it says, what's the protocol using which we can communicate with that device? I'll say SSH. Then it says, what's the iOS that it is using? I'll say iOS itself. Then do you have more devices that are available in your inventory? Yes, I do have. And then repeat the information. So what's the next device? I have R2, the IP address of which is 10.255.1.102. The protocol is SSH and the platform is iOS. More devices? Yes. The next device is R3. And then we have the IP as 10.255.1.103. The protocol is SSH and the OS is iOS. And the last device, of course, which is R4. Then we have 10.255.1.104. The protocol is SSH and the OS is iOS. There are more devices? No. And it says that the test file is created, which is my testbed. So in exchange at the end, how does the test file looks like? I can just say check disk webinar ls, and you will find out that file, which is not over here, I think. I'll go to the parent directory and say ls, and you have got my testbed.yml. So if I go and say more, my testbed.yml, there you go. That is the content. So we have devices in which we have first device as R1, the connections according to CLI is this, the credential is this, the enabled password is Cisco, which we are not going to use. The operating system is iOS, the type is iOS. Same you have R2, same you have R3 and R4. All these devices are available. Now that you have created the test bed, then we are kind of going to, let's say, run our first test towards our device. Now, the beauty of pyATS, or the beauty of one of its library called Genie, is that it has a lot of built-in knowledge of how the networks operate. So we're just going to tell the pyATS to learn everything about the OSPF technology, let's say. Okay, that OSPF topology, not technology, that is available over there. If I say Genie and hit enter, then you can see that with Genie, you can use these commands. There is a command that says create testbed, which we already have used. Then there is develop, which basically puts desired pyATS packages into the development mode. Then we have diff, which is basically to compare the configurations. Then you have DNAC, which is basically command to learn DNAC features, right? Which is DNS center. And then you have learn command, which basically is a command to learn device features and save the file. Then you have parse, then you have run, then you have shell commands and so on. Out of which we're gonna execute the learn command. So if I say Genie learn and hit enter, it requires some information. So when you use Genie learn, it says no testbed file is provided. You can execute Genie learn --help. Now, if you say Genie learn --help, it will help you with all the parameters that Genie can help you use it. If you scroll up there, for example, it will help you to learn the OSPF information. So these are some of the example executions that you can do. Okay, and the technology can be executed. It can be BGP, it can be something else that you've got configured on your devices. So if you even wanted to list all the feature to learn, then you can basically specify all the optionals over there. What we're going to do is we're going to execute a command that says Genie learn OSPF. So it will learn about the OSPF information that is there. And I will provide my testbed file, which is my testbed.yaml. And I want to store the test output into a file called my webinar, or you can say webinar output dot. I think webinar output should be the thing. No extensions are required since it is going to create just a text file. When I execute this and try to hit enter, there, learning OSPF on devices R1, R2, R3, and R4. See, there was a log that someone tried to sneak into the device using SSH. Takes a bit of a time to learn that. If I go on R2, it has reached, on R3 also, and on R4 also. There, 0%. And there. Oh, we've got some error that says failed to connect to. Oh, okay. I think the fingerprint of the SSH must not have been identified. So we will first kind of try to ping to our device, that is 10.255.1.101. Communication is working fine. Then if I go 2, that is also fine. 3, that is also fine. And 4 is also, so communication is fine. Let's check the SSH. admin@10.255.1.101. Okay, so we kind of have to accept the SSH keygens. The fingerprints are not verified. That's something that I'll have to do by using this command. So for 101, it is done. Then for 102, then for 103, and for 104. Then SSH admin@test. There, accept fingerprint. I'll say yes. Login using Cisco as my password. We are in. Similarly, I'll have to say 102, accept the fingerprint. Since we are in test environment, we can encounter this. 103, accept the fingerprint, Cisco, and exit. And 104, accept the fingerprint, Cisco, and we're good. Now let's execute the test again and check if that works. So there. There, learning. Shall gather all the information. And there. So you see the test is executed 100%, and Genie learn summary from device R1. It says connected to R1. The log from that device is stored into r1.txt or connection_r1.txt in the webinar output folder, and learned feature OSPF. So it has learned about the operational structure, and it has learned about the device console information. Same thing it has did for R2, same for R3, and same for R4. Let's check how this information looks like. If you see, we will have a folder called webinar output. I'm going to jump into check disk, webinar output, and say ls, and you will see that these are all the files, out of which we have connection R1 and OSPF iOS R1 console. Then we have OSPF iOS R2 exception, and then R3 operations and all that stuff. So if I say more connection_r1.txt, you see it has stored all the executions that it has did onto the device. So whatever the log messages of that device was, it is stored there. Then if I say more OSPF_iOS_r1_console, then it shows me it has executed a command by itself, that is show IP OSPF, and whatever the logs are there, it has stored that. Similarly, it has executed the show IP protocols and stored the output. Similarly, it has executed the show running config pipe section router OSPF1, and it also has executed show IP OSPF MPLS LDP interfaces and certain other commands which helps it to identify all the OSPF configuration that is available onto the device. Okay, once these are basically the list of all the commands that are executed, right? Parsed commands. All these commands were executed, and the output was stored into this file, which was OSPF iOS R1 console. Then it also has stored the operational information. So we can say more OSPF R1 ops. .txt. And you can see it has created JSON kind of a file, which has information about all the OSPF configs. So what all are the areas? The area ID is 0000, which means 0. Then the database information, what all are the routes that it has generated, right? How many routes are available and so on, which helps it to structure the data that is present onto the device. Now the magic comes up. Let's say that there is something goes wrong in your device. Okay, for example, I took this particular backup, or I performed these learnings of my network inventory today, and maybe a couple of hours later, we got a message from our team that there is something wrong. I am not able to communicate. For example, I go to my topology and I turn off this link. Okay, I say go to R2 and turn off GI0/2. So if I go on R1 right now, and if I say ping, so yeah, ping 40.0.0.1 saying source loopback 0. There you go, the communication is working. So I'll go to R2 and I'm gonna say enable config T interface GI0/2 and shut down and take an exit. Now my interface is down, my OSPF neighborship goes down, and then there will be routes which will be removed. So if I now try to communicate, it doesn't work because there is a link which is down. In a larger environment, it will take a bit of a time to identify what's the problem. You might check the next hop where the path is failing and all that. By pyATS, what I'll do is I will try to execute the script again. So I will go to my parent directory and I'm gonna say execute the Genie learning for OSPF again. There. And now I will say webinar output _new. That's where I'm gonna store it. So execute it. It will again learn about the information, the current scenario that's available there. And there, the learnings are done. And you also have your outputs. If I go webinar output _new, same learnings are available. Same files are there. So we can check these files and all. What I can do now is I'll go to my parent directory again, and Genie or pyATS kind of allows you to do comparison between the baseline configuration and the current configuration that you just have learned. So I can go and say pyATS and use the differentiation command diff, and then the first output, which is webinar output, and the second output, which is webinar output _new. These configurations can be done. Oh, sorry, these comparisons can be done. If I hit enter, and there, so you see that Genie diff summary between directories webinar output and webinar output new are there. So there is a difference which is available in the operations of R3 operations on R3 device. Then there is R4 is identical, which means nothing is changed. And on R1, nothing is changed. But between R2 and R3, there is something wrong. So if I kind of go and say, check disk webinar output _new, and then say more, I think the file is available. Just a minute. Yeah, there. So we have a file there, diff. It has stored the output or the differentiation there. So if I say more diff on R2 and there. So you can see over here the information, the default address. So it says the information is this, VRF, there is no VRF, no default, no address family. Instance, OSPF instance is 1, area 0, interface gig 0/2. Enabled was true, but now enable is false, which means the GI 0/2 interface is down. It also have affected the neighbors. The neighbor 3333 was there. So the minus command, if you see here, this means that this part is removed from the current configuration, which was there in the baseline config, and plus sign highlights that the current state which is available. So enable true was removed and enable false was kind of added. And due to this, all these commands or all these, the state that you see below was removed. So that kind of gives you a heads up. Again, if I check on the other device, which is R3 operations, there also you can see that no interface changes are there. The gigabit Ethernet 0/2 is there, but the neighborship information is removed, which kind of gives you a hint that there is some interface configuration change on R2, not on R3, because R2 state says the configuration has been false. So that helps you to instantly go on R2 and then check show or do show IP interface brief. And then check that the interface is down. So you possibly might go there, interface GI 0/2, and no shutdown and take an exit. And your neighborship will be back again. And then you can again perform the checks and learnings. However, it has been resolved. But such kind of network validation test helps you identify issues and then even compare configuration, takes backup of your configurations or create a baseline healthy configuration file. And you can compare that healthy configuration with the current configuration every time you get a fault there. So that's somehow some of the use case of how pyATS helps you to identify the issues or to perform network tests on how your network is performed. Again, this is kind of a limited use cases of how pyATS can help you. And there can be Python scripts which can be created and deployed and scheduled based on how the configuration or how the network is performing. Very useful tool towards it. And that was the motive of us to highlight how the pyATS framework generally work and help you towards performing tests in your inventory. If you have any questions, guys, please put them into the chat and I'll be here to help you. I see Radhika saying that if the lab was ready, we could have learned more about pyATS rather than the network basic. Well, I prefer to keep everything from scratch. If I keep everything ready, then it doesn't give learner a good understanding of what we are testing based on my experiences. That's why it just took, I think, 10 minutes of our time from the total amount of webinar. And the time of the webinar was quite flexible. So nothing to worry about that. Do you guys understand what we just discussed about? You can just put your thoughts onto the chat. If understood, yes. If not understood, no. Or if you have any question, ask them. So such kind of concepts are basically covered in some of our trainings that are upcoming next month. The concept has been highlighted strongly into CCNP DevNet certifications, as well as the DevOps for Network Engineering course that we have just launched. Since DevOps for Network Engineers is a custom course that we have designed in order to meet the prerequisite for those who are aiming their goal as CCIE DevNet certification. So it's kind of a set of tools that we're going to cover. pyATS is one of it. And we have Terraform, we have NSO, we have CI/CD pipelining, GitLab, and lots of other tools that we are going to play with, including Ansible and other stuff. So if you feel that the webinar has somehow helped you, you can go watch that webinar again, since the webinar will be made available on YouTube and so on. We have a question. Pranav says that when G0/2 was shut down, OSPF should have made a neighborship over G0/0 with R3. No, it will not, because we did not make G0/0 as part of our OSPF configuration, right? If we would have advertised it into the OSPF, then it might have did that. But since G0/0 is not participating into OSPF, it will not. If I show you the config, show run interface, there is no IP OSPF 1 area 0 command. However, if you see show run interface GI0/2, you'll find this command there. So since GI0/0 was not making neighborships over its link, it will not do that. And great, I think we're pretty good. If you feel like exploring such technologies, and if you want to have such webinars organized on the topics which are more important, you can just go on to pynetlabs.com and explore our courses that we have. We do often have a lot of webinar schedules, mostly every week. I think some of them would be delivered by me, some of them would be delivered by our other people that we have. So if you see, we have a column that says DevNet training that will help you identify the content that we learn about it. So this course kind of prepares you with all the DevOps tools that can be used, focusing towards the network automation implementation. So we have introduction to DevOps and Net DevOps, then the recap of standard network automation, the VCS, Git, GitHub, GitLab, fundamentals of CI/CD, Ansible, working with pyATS, some of which we explored today, Python Jinja 2 framework, then Docker container and Kubernetes, and then performing configuration telemetry, changes using Terraform and all that. You would also see the lab outline and so on. And most of our, we also often keep on uploading blogs, which will help you to go through some of the scenario-based terminologies. For example, who is eligible for DevOps, is DevOps, or is DevNet same as DevOps, network automation using DevOps, right? And certain other blogs like that. That can also help you to, you can say, make your thoughts clear about what you should do and what you should not, including like a guide for Cisco certification updates, is CCNP harder than CCNA, what is NetConf and all that. So keep yourself signed up for all the events and trainings that we do. And if you feel that there is something that you need to ask about or that you need to inquire about, feel free to drop a WhatsApp or call on the number that is highlighted onto the website, and you will get all the help that you require. With that said, I think we can conclude this webinar. That was all that we had to talk about. And thank you so much for your time, and looking forward to see you again in some other webinar. Take care. Have a good day ahead. Bye-bye. Thank you.